Hello. So, in lesson 2.6, we're going to look at combinations of functions and composite functions. Um, so first, what we're going to look at is the domain of the function. I know that we did this already a little bit, but we just want to make sure that we're kind of reviewing it here. So finding a function's domain. If a function does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So exclude from a function's domain real numbers that cause division by 0 and real numbers that result in an even root, such as the square root of a negative number. Okay, so let's look at a function g of x here, which is 5x over x squared minus 49. So what we're looking at here is when is this function undefined? So we want to first figure out when is it undefined. And it is undefined when the denominator is 0. We cannot divide by a 0. So x squared minus 49 cannot equal 0. So we're going to solve for x, and when we solve for x, we get positive and negative 7. So this, um, so if we would plug these in, we would get undefined because that would give or set the denominator to be 0. So we need to exclude these from the domain. Normally, I mean, if we look at our function g of x, our domain would be just negative infinity to infinity. Now, we have to exclude the negative 7 and 7. So the way we're going to do it, we start from negative infinity. We say that negative 7 is not included. So with the parentheses, it means that it is not included. And then we continue from negative 7 all the way to 7 again, and both we're showing with the parentheses again that negative 7 and 7 are excluded. And then we continue from 7 to infinity. So that would be the domain for this function g of x. Okay, next we're going to look at sum, difference, product, and quotient functions. So we've got f and g that are two functions. And first, so we've got the sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domains are the set of all real numbers common to the domains of f and g, defined as follows. So what we're going to do is we're going to start with the sum f plus g here of x. This is the same thing as f of x plus g of x. Difference f minus g of x is the same thing as f of x minus g of x. And product f times g of x is the same thing as f of x times g of x. And then we have our quotient f divided by g of x, f of x over g of x. And g of x does not equal 0. Again, we can't divide by 0, so that's why it doesn't. Okay, let's look at combining functions. So we're going to use what we just did here. We have f of x and we have g of x, and it looks like we are adding f plus g of x. So f plus g of x is the same thing so right here is we can rewrite it as f of x plus g of x. So we're going to start with f of x, which is x minus 5, plus g of x, which is x squared, minus 1. And now we're combining like terms, and we get x squared plus x minus 6. Now, we need to determine the domain of this function. If we look at f of x, there are no restrictions, none. And if we look at g of x, it's the same thing, no restrictions. So that means that our domain of f plus g of x is going to be all real numbers. So negative infinity to infinity. Okay, next we're going to look at composition of functions. So the composition of the function f with g is denoted, and there's not enough room here. It has like a circle in between. So it is not a dot, like a multiplication, a product. It is a circle in between. And this is defined by the equation f of g of x. The domain of the composite function is the set of all x such that, hold on a second, I'm missing here. The domain of the composite function so 1, x is the domain of g, and 2, g of x is in the domain of f. Okay, so forming composite functions, we have here f of x equals fx plus 5, fx equals 5x plus x. And then we have g of x, which is 2x squared minus x minus 1. And then we're given the composite function that we are writing. Now, I like to use the form where they're kind of inside. So I don't know. I feel like it's easier for me to start with or know which one goes inside which one with this form. But that's, up to you. Okay. We have f of, and g of x, instead of writing the g of x, we're going to write the 2x squared minus x minus 1. So now this part here is going to go inside the function, or inside it. This part here is going to be written in the f of x instead of the x. So we have 5 times x. So now instead of the x, we're going to write 2x squared minus x plus minus 1. And then we can't forget the plus x, or plus 6, sorry, from here. So instead of this x, we wrote the 2x squared minus x minus 1. Okay, next we need to distribute here. So we get 10x squared minus 5x minus 5 plus 6. So our composite function is going to be 10x squared minus 5x plus 1. And again, neither f of x or g of x has any restrictions, so our domain is going to be all real numbers. Okay, now, next we're going to look at excluding values from the domain of a composite function. So the following values must be included from the input x if x is not in the domain of g. It must not be in the domain of the composite function either. So any x for which g of x is not in the domain of f must not be in the domain of the composite function either. Okay, let's go ahead and look at an example here. So we are forming a composite function. Now, if we look at f of x and g of x, we need to, so it's the g of x that we're going to look at the restrictions. So for g of x, which is 1 over x cannot equal 0. So we need to keep this in mind when we are doing the composite function. And we're going to go ahead and now see what we get or how we form the composite function. So f of g of x, which g of x is 1 over x. And now instead of x in f of x, we're going to use the 1 over x. So we're going to go ahead and write 4. Hold on a second. So now I'm plugging it in here. 4 over x is 1 over x plus 2. We cannot have a, or we need to get rid of this x right here. So what we're going to do is we're going to multiply both the numerator and the denominator by x. So 4 times x is 4x. And then this x cancels this out. So that's going to be 1. But then we are multiplying both of these. So we're adding 2x onto it. So this is our composite function right here. Now, we already excluded the x cannot equal 0 here. Well, we need to look at this one as well, the composite function. We cannot have 1 plus 2x. Actually, let me do it here. 1 plus 2x cannot equal 0 either. So we're going to move the 1 to the other side. It becomes a negative 1 and then divide by 2. So we get a negative half. So we need to exclude both the 0 and the negative half from the domain. So our domain for the composite function is going to be negative infinity to negative half. And then we're going to continue with negative half. Again, parentheses tell us that it is not included. If we had the brackets, it would be included. Negative infinity to the next restriction, which is the 0, and then going from 0 all the way to infinity. Okay, so actually, you know what? What we just did is This answer should be here because this is asking to find the domain of. This was only asking to find the composite function, not the domain. Okay, next one. Now we're going to write a function as a composition. So we've been doing now we're going to do the opposite. And for this, there might be a couple of different options. Um, you know, what we're trying to do here is we're trying to find um, the composite function. So what is the g of x and what is the f of x? So the way we can start looking at our composite function h of x is that we take whatever we can from the outside. So for the f of x, we could do square root of x. So now what do we have end up inside after we do take the square root of x? We have x squared plus 5. So these would be our functions that we are combining. So let's plug it in. F of g of x, so f of x squared plus 5. And our f of x is the square root, so we do square root of x squared plus 5. So we know that we did it correctly here. Okay, that's it for this lesson. Let me know if you have any questions. Bye.